Thank you, Pradeep. My name is Raj Bhagat. I work in World Resources Institute, and we are actually uh, a research to policy organization. So, as a research to policy organization, actually, we use a lot of data, and I'll be just showing you how Google Earth Engine has helped in it. And also in scaling of our research. So. So I work in urban development and water resources. One of the key problems that we face in India, at least, is the massive urbanization that has been happening in the country since 1990, and uh, using standalone computers and everything, people have been doing classification for a long period of time. But right now, since we are focusing on a vast geography of India, and you need massive computing and for this massive data, we have switched to Google Earth Engine actually. So some of you might have been trained in how to classify images for the basic landforms, etc. During the previous webinars. But there are so many versions of land use land cover classifications. So many results have been achieved, each one differing. There are lots of these things that have come up post Google Earth Engine's opening up of platform, and I'll show you some of the results that have come from us. What we did was we were studying actually 18 top 18 cities in India, and we wanted to see how they were growing at least within a 50-kilometer radius from the center of the city. So what you can see the statistics that's seen over here. It's a massive expansion, 5,400 to 10,600 square kilometers within this region, and this is where entire India has been moving. These are the biggest 18 cities. But when we go to the government, it has become like
Raj, you may be
I
on the wrong slide. I can still see in the first slide, I think, of yours.
sorry, is it moving?
Yeah, I can still see a slide, algal bloom observations. That's the one that's on the live stream. If you are switching slides, okay.
Is it fine now? Sorry, is it fine now?
Yeah, it's fine now. But you can still make it full screen.
It is full, I guess. Give me a minute. Is
Okay,
it?
go ahead. Go ahead.
Yeah,
Sorry.
sorry, guys. You can notice the statistics that it has grown pretty fast. But governments need more information from this. It's not just where it is expanding and when it expanded. They also wanted to know like why is this expansion happening. So here we used Google Earth Engine in a very new scale, a machine learning on the top of machine learning to figure out why urbanization is happening. So we came up with this model using a lot of ground data, using the machine learning methods in Google Earth Engine. We came up with this model, and it tells like what is the characteristics of urbanization. That is, whether the urbanization in that city is just because the town is expanding, or if it is a new special economic zone or an industrial area coming in, or it is just the neighboring town that is expanding.
So
So
Raj, sorry to interrupt again. I think your slides are still showing the algal blooms, so we are not able to see the correct slide.
okay, I'll reshare. Sorry, I'll reshare again. Is it fine now?
Yeah.
So which is the slide you want to be speaking to, and we will confirm whether that we are seeing that.
Is this the monitoring urban expansion one?
Right. And can you just navigate one or two, and we will make sure it's happening?
Understanding urbanization is the one right now. Yeah, great. The land use land cover maps were created using Google Earth Engine, but we wanted to build upon that data. So we went with another machine learning model over the existing land use land cover maps, which is to understand what type of urbanization that is going on. That is, whether is the town expanding or whether it is a special economic zone. So I have just shown the results over here. It is a machine learning model that was built initially for Bangalore, and later we expanded it for all the 18 cities. So the area in red is shown as the sprawl or infill, that is the town expanding on itself. And then the areas in blue are special projects like airport or industrial area. You can see the Bangalore airport in the north. You can see the Jigani Bommasandra industrial area and the Bidari industrial area that is shown in blue. And the neighboring towns are shown in yellow. That is a small town or a village that began expanding because this city began expanding. So you can see Hosur expanding pretty much, and that kind of thing. And the green color indicates corridors. That is the development that is happening in corridors. This data is pretty useful for the government because you can now understand why this urbanization is happening and what is causing it, and whether we have plans in place for that. For example, the corridor expansion, there are no plans. So in order to do that, this is a idea that we had in our heads, what we see when we see in roads, and we wanted to do that in a machine learning environment, and using Earth Engine we did that. So the best part about Earth Engine is that you can scale this up. That is, it is not just Bangalore you will be able to do for the top 80 cities. So this is the result that came out of it. You can notice that for some cities like Delhi, the expansion of other towns, which is shown in yellow, is nearly 63%. That is, Delhi has these Gurgaon, Faridabad, Ghaziabad, and Noida. Those are expanding in a pretty big scale. So these kind of things, and in some cases like Jaipur, it was just the city growing larger in its peripheries. So you can see the red in that 67%. And also in some cases like Nagpur or Surat, you can see that the majority of the growth is happening because of strategic projects. These are SEZs and those kind of things. In some cases, the corridor expansion is pretty high. So this begins, this kind of insights we were able to build because of the Earth Engine platform, and we were able to test it, and we were able to scale it easily. And otherwise, it's everyone knows. I think it is downloading all these satellite images and testing it, etc. So the availability of the machine learning models and also the data made it simpler for us. So this is one of the research, and we were able to inform the government what is causing the growth and where it is focused, which allows them to build plans, for managing this expansion. So the other work that we do is monitoring water bodies using Google Earth Engine. So currently, actually, we have a model that works for surface area monitoring. That is the area, how much it is growing, etc., etc. So this is the sample here is from the Kaveri watershed. So you can see that in this monsoon, how it began filling up using radar data. So we built a model over that to calculate the surface area, which is shown in the graph in your left side, and you can see through the monsoon. This is the chart is actually from 2017 because we just thought it will be good to show that. So we have been doing this for 2 years right now. So to see which lakes have been expanding and which have been shrinking, etc. So this is for surface area. Currently, we are trying to integrate some ground data with GPS devices to bring in volumetric analysis in it as well. So we are expecting this to be ready by this year, and that is the thing. So biggest problems that we face in remote sensing is that we have to provide right data at the right time at the right place. So when we have issues, for example, if we are dealing with some events, say it is flood, landslides, or crop fires, these are events that could happen in any place at any time, and we will not be able to easily predict it. We can predict it, but it will be very difficult, and that means you have a very short frame of time to map all these. In such cases, Google Earth Engine has been very, very beneficial. So what you see is that the flooding in Kodagu, we were able to map to a little bit, at least in the agricultural fields, which was pretty much a starting point for mapping the floods. The other work that we did for Kodagu is Coorg district in Karnataka, where there were immense landslides during the last August. and we began classifying Sentinel-based images to obtain the areas that were affected by the landslide. So what you see over here as a in the left side as a GIF file is the extracted landslide affected area that is draped over Google Maps satellite version. So before landslides and after landslides, you can see how much it has affected, and you can thereby calculate the area, etc., etc. So many NGOs and the government has been using this data. They wanted, we ourselves have been recommending them to come into Earth Engine so that they can easily do it by themselves. So the other issue that we recently had to map was crop fires, and you can see that this was an animation. Actually, the code for animation was developed by Janadi, I think, and we use the same for animating across crop fires, and you can notice how they were happening in Punjab and Haryana. So we brought up statistics. This data is actually from MODIS, and we were able to track how many crop fires are happening in Punjab and Haryana in each district and taluk actually. So that is one. There is an app as well. We had published it some time ago that will give you where the crop fires happen. So the new app feature, which is pretty much like a WYSIWYG type, and it is pretty easy because we can test it in the on the go. We have been doing some kind of algal bloom observations. Algal blooms are the ones that happen over the lakes due to increased phosphate content. This is pollution. And it happens usually in the mid course of a river. If there is a dam or something like that, it will happen. So we created an app for the government and the public to view where these algal blooms are happening. So you can see all these green, fluorescent green, etc. So these algal blooms are, some of them are toxic. Not everything is toxic, but it is a good indirect indicator of water quality. And we created an app. Actually, it was a very, very easy one. So it was just click and go, etc. So you can choose the reservoir that you wanted to visualize, and it will show whether show the algal bloom observations that are made in that time period. So the other app that we developed was for Chennai. We were using the same classification methodologies and the thresholding actually on Sentinel-1 radar data. And we were able to create this app where you can slide through between 2017 and 2018. And in 2017, you can see a lot of these lakes are full, and in 2018, you can see that they are pretty much empty. And this was very, very helpful because we were able to create a massive awareness campaign on how the water crisis is growing in Chennai. And actually, right now it is still January. February right now, but by June or something like that, Chennai will be in a very deep crisis. So before the crisis happens, we wanted to warn them, and the app was pretty helpful, and also the data from that. So you can notice that the big one is the Chembarambakam Lake that was flooding in 2015, and this year it is not having even 5% water actually. So these kind of things we were doing a lot of these using Google Earth Engine actually. A good majority of the concepts, it's not just about doing all these. Before the advent of Earth Engine, we were not sure whether we will get the intended results. We were not able to test it in the sense if testing takes lots of our resources. We have to download the images, we have to spend time in processing it, etc., etc. But now the testing and scaling has become pretty easier. That is why we have been shifting most of our research to Earth Engine. And
Raj, just a time check. Could you close up in a minute? Okay.
I'm done actually. So you can reach out to me personally, or if you have questions, just post it.